creates a database. And if you look at the comments in there for these Diana tables, it actually tells you that a row with a value of 0 is Diana, and one with a part number of 1 is portable P code, and one with a part number of 2 is machine-dependent P code. And again, at the bottom, we've just got the source dollar table where the actual source code is stored. Recursive SQL. Don't want to get into details about how Oracle database works, but it's relevant for what we're going to look at next. When you run a piece of SQL, for instance, I might type in execute procedure A as a user Scott. Oracle has to do a lot more work in the background before it can actually execute that. It has to go and get the source code for the procedure or the machine code, load it up ready to execute it. It's got to check the privileges, it's got to go and look at indexes, lots and lots of different things that it needs to do in the background. That's generally known as recursive SQL. So even though it's running as Scott, sys actually does a lot of work in the background first. It's possible to see what happens, which we'll look at next. So when compiling PLSQL, there are a lot of other background processes, SQL statements that need to run as sys. So these could be privileges, triggers, for instance, retrieving the PLSQL source code or indexes. So how can you see the complete picture? Well, it's possible because Oracle provided a wait interface. So they've instrumented the Oracle kernel and allowed you to trace how the Oracle kernel works. And you can set trace, different level of trace. You can set some special events that do different things. The general trace event is 10046, and you can set that to run at different levels. You can either just get the simple trace, or you can get the bind variables on the wait events as well. It's also possible to dump data from the shared memory segments and also from data files in the database with dump commands, which we'll look at later as well. So assuming we wanted to trace the compilation of our simple procedure, then we just use an alter session command and set the 10046 event, which is actually just trace. And we tell it to be level 12, which says we want to see the bind variables and the wait events as well. And then we create the procedure, and then we have to turn the trace back off again. And that gives us a trace file, which I should have here. Not that one. I think that's this one. Okay. So the bit on the slide is just pulled from this trace file, but it's easier to see it in the context of the trace file. So the actual database is doing a lot of work. It's doing select count star from IDL UB2$. It's deleted the contents of IDL UB2$, and then it's doing an update. So it's actually putting, because we're doing a compile, it's actually loading the Diana into the IDL UB2$ table. And you see these values here. These look familiar, 1D, 17, 9A, 68. These are the same values that we could actually see in the wrapped file there. So you can see that that's the Diana, and it's putting it into the internal dictionary tables. Hence, those numbers look familiar. So one thing to look into to see the usefulness of this is that what we needed to do was check these IDL tables to see if these tables always store Diana, because we now know that Diana is wrapped PLSQL source code. Is the Diana stored for every piece of PLSQL in the database? Unfortunately, it's not. This piece of SQL is just doing a union on the 4 tables, and it's just selecting a count, and it's I'm trying to find the cursor so I can point at it. It's just highlighting which table it's coming from. Highlighting the table it's coming from, looking at the part, the object type, and so on. And we're looking for part 0 because that's Diana. And we're just seeing which types of objects have Diana stored in the database. So that's operators, procedures, type bodies, functions, packages, which is the actual package header, not the package body. So for package bodies, the Diana is not stored in the database, but the M code is. So if you wanted to unwrap PLSQL, it's probably not going to be feasible to unwrap all PLSQL from the database because it's not actually stored. Oracle throws it away after it's compiled it, doesn't keep it. So we want to look at the IDL that was actually created for our simple procedure AA. These SQL scripts are available on the CD because they're quite long to type in by hand. Sorry.
So you're saying that the database doesn't store dynamics for all packages procedures and store encoders?
It stores the M code for all PLSQL, as far as I'm aware, but it only stores Diana for some types of PLSQL.
And then if you do restore the database onto a different architecture platform, what's going to happen to that?
They get installed because it's platform independent. It's running in a virtual machine, so the environment is just an interpreter. So it's a PLSQL interpreter.
The encode is not platform specific.
No. So we wanted to actually see what Diana was created for our simple procedure. So I've created another big lump of SQL here that looks at the 4 tables, and we're actually pulling out the row IDs because we want to be able to dump the contents from the data files, which will become apparent why in a minute. So I've actually pulled out the actual blocks, because Oracle stores data in blocks on the file system. And the size of those blocks are configurable, and there are lots of different types of blocks. What I've done is listed out the file number and the row number and the block number, which will become useful in a minute. And the actual table it's come from, and I've highlighted the UB2 one because we've already been looking at UB2, and that's where the Diana nodes are stored. Part number is 0, which is Diana, and piece number is just there are, in this case, 5 different pieces of Diana, and 3 pieces of M code, which are the parts 0 and part 2. And the length is 123 bytes. So on this slide here, what I was trying to do was select the actual Diana from the IDL UB2 table. I found the object identifier for obj$ for where my procedure is called AA, and I try and select out the Diana for piece 4, which is what we highlighted in the last slide. But you can't do that, it fails. Or a 932 inconsistent data types, because the actual data type used in the IDL dollar tables for the piece column are actually undefined. They're not implemented through the normal SQL interface. I guess it's possible to actually select from them somewhere, because Oracle is actually doing it internally. So if you look at the statements that are generated in the trace that we looked at a few slides ago, Oracle's actually doing selects on those tables, including the piece column. So clearly it's possible to do it, but at a lower level in the Oracle kernel. But we can't just do it in SQL+. So the way to get the actual data is to use a dump command, which allows us to dump data file 1, which in this case is the system table space. And we want to get that block number, which is the one that we actually identified with the SQL in the previous slide. So that does a dump, and that actually dumps it to a trace file. You can then scroll through the trace file, and because I wanted row 8, you can see here it's row 8 at the top. So I've actually scrolled through and found row 8 for that table. And again, as you'll see, the highlighted, the bolded values, 171D, 689A, are obviously familiar. They are the Diana. Okay, a little detour. So what does Oracle use IDL tables for? It's always interesting to spread your search a little bit. There's quite an interesting view called DBA dependencies that you can use in 2 directions. You can see for a particular object which other object it relies on, or you can go back up the chain and do it the other way. So you can see, for instance, for a particular table, which other objects use it. And I've just done that for the IDL tables, and you find that all of these objects actually use the IDL tables for something. Some of them are views for actually looking at, like for instance, parse pieces is the actual looking at the size of the PLSQL that's in the database. So people who are interested in tuning and sizing would look at this. But it's quite interesting that, for instance, in init JVM orgs uses it, which is the Java virtual machine. And probe at the top is the PLSQL debugger. That's the old name for DBMS debug. It used to be called probe. So just looking at one of those as an example, code pieces. Just describing the view doesn't tell us anything, but we can select the text for that view from DBA views, and the text is on the right hand side, so it's just doing a union of the IDL tables, and presumably that's used for sizing to find out how much M code or P code or Diana is actually installed in the database and how big it is. The next is what we want to look at is the interfaces that Oracle have provided to the Diana and the IDL. They provide two packages, one called PIDL and one called Diana. I've actually just got these in TextPad, so a bit easier to see. The Diana package is called Diana. For a valid Diana implementation, any implementer, this is particularly aimed at Ada, but I guess it applies to PLSQL as well, is that they need to provide a package like this that provides certain operations that are available to act on the abstract data type. The interesting part that we'll just look at here is the actual names of the Diana nodes. So we can see things like dabort is the name of a Diana node. For instance, d_conf_u is the name of a Diana node. We'll come back to them in a minute. The PIDL package is package portable IDL. There is lots of definitions of data types and sizes that are used throughout the PIDL package and also the DI utility package that we'll look at in a minute. And there's some interesting functions, these that are on the screen now. PTF_kin tells you the type of a node. So if you actually know the value of a node, for instance 9A that we saw previously, you can actually get the type of that node. So you can see if it's dcompu, for instance. So I pointed the wrong one, it's that one. Then there's some interesting functions here that tells you the number of attributes that a particular node's got. It'll tell you the text name of the node. It'll tell you the text name of the attributes as well. So that's quite interesting. We'll see them again in a minute as well. So both of those files are available in the Oracle Home RDBMS admin directory as PIDL.sql and PIDian.sql. And they provide an API to Diana, which, as we now know that PLSQL, wrapped PLSQL is Diana, it's providing an API to the wrapped PLSQL as well. There's another interesting file called diutil that's got some functions in it, which I think I might have opened in TextPad as well. No, I haven't. Let me just open it. Diutility provides a function called pstub that was provided by Oracle. We'll come back to this in a minute, but I'll just show you this package. It provides a function called pstub that's in a separate file, but it's actually then calls the pstub in diutility. And if you scroll through this file, you can see that it's actually using Diana stuff as well, because you can see in there there's the Diana functions. For instance, there, Diana.aUnitB to get the attribute that's pointed at from a particular node for the aUnitB attribute. So that's diutil. Again, it's in the same directory. Oracle also provided another useful script called dumpDiana, which does as it says on the tin. Again, that's in the Oracle Home RDBMS admin directory. It's not installed by default. You have to run the script as sys or as internal with an earlier version of Oracle. If you try and install it, you'll find that it fails. You have to fix 2 bugs in it to make it work. There's actually 2 lines with rem and then a lot of dash symbols. If you actually remove those, it installs and compiles properly. You need to check that the Diana PIDL, and the diutility packages are there as well. Then you can run dumpDiana, which is what's shown at the bottom of the screen, and just pass in the name of our simple procedure, and it creates a trace file, which I'll just show you a clean one because it's a bit easier to